everyone, welcome to my presentation. My name is Dolly Sharma and today I will be explaining my project titled Car Selling Price Prediction using Machine Learning. The aim of this project is to build a model that accurately predicts the resale price of a used car based on various factors like manufacturing year, kilometers driven, fuel type, transmission, seller type, and number of owners. For this project, I used the real world data set car details from cardeco.csv, which contains detailed information about hundreds of cars sold in India. Let me now take you through the entire step by step process of how I built this project. The models I've implemented and compared with linear regression, random forest, XGBoost, regressor, neutral network. The first step I did was that uploading and loading the dataset. The first step I performed was uploading the CardEcho CSV file into Google Colab. After uploading, I read the dataset using pandas and confirmed that the file was successfully loaded by viewing the number of rows and columns. This gave me the initial structure and size of my data. Here, in this step, the data has been loaded and I can see the table of the data of, of the number of cars, their selling price, kilometer driven, fuel, seller type, transmission, and their owners. In the next step, I have explored the data using data types, missing values, and basic strategical summary using df.describe data type and df.info data type that helped me understand which column are numerical, which are categorical, whether there are missing values, the overall distribution of the data sets. In this step, in this next step, exploring the data structure distribution analysis. As a part of feature engineering, I created a new column called car age, which is equals to 2025. This new column was important because the car's age is a major factor in determining its selling price. Visualizing the data distributions. After that, I have created a plot and some heat and some graphs and maps. Here I'm visualizing the data distribution. After that, I started analyzing the behavior and distribution of the important variables. I plotted selling price distribution, kilometers driven distribution, cars distribution, count by manufacturing year. These visualizations help me understand how the data set is spread out and whether the values are skewed. In the selling price distribution graph, it shows the selling price of cars are distributed in my data sets, which shows most cars are sold at lower prices. The left sidebar of the graph has the highest bars. As the price increases, the number of cars decreases. As the price increases, the number of cars has been decreased. This is the common use car data. Cheaper cars are more common than expensive cars. And the driven distribution, how many kilometers the cars have been driven. Most cars fall between 20,000 to 60,000 kilometers. Very few cars have extremely high or extremely low mileage. The distribution is peaked, meaning many cars have typical moderate usage. The car's distribution shows how old a car is, your data sets are. Interpretations, most cars are 5 to 15 years old. Very old cars, 20 plus years are very few. Number cars less than 5 years old are also less in number. Used cars market mainly contained cars around 8 to 12 years old. The count by manufacturing graph shows how many cars were manufactured in each year. Interpretation, the highest number of cars were manufactured between 2010 to 2015. Cars from the 1990s are very few. The newer years like 2016 2020 shows fewer entries because the dataset will contain fewer recent model cars. In this step, I've analyzed categorical figures to understand how category based columns after price are used, box plots to compare fuel type versus selling price, seller type versus selling price, seller type versus selling price, and transmission type versus selling price, owner category versus selling price. From these graphs, I have derived some clear insights which are diesel cars generally have higher resale value. Dealer sold cars are priced higher than individual seller. Automatic cars are usually more expensive. First owner cars get the best resale value. This insights help me understand the relationship between categories and selling price. The next step, I have performed data preprocessing. In this preprocessing stage, I performed several crucial steps, mapping owner labels to numerical values. Example, first owner first, second owner second, and so on. Labeling encoding, I used fuel type, seller type, and transmission. Dropping irrelevant columns. The car name is not needed for prediction, so I dropped the name column. Scaling numerical features, I use standard scaler to standardize year, km driven, car age. Finally, I separated the data set Y and and finally I separated data set into X all features, Y targeted variables. Visualizing relationship and heat map regressions. To understand how features correlate, I plotted a heat map. I've also plotted regression graph, car age versus selling price, kilometer driven versus selling price, year versus selling price. This helped me visualize new cars have higher selling price, more driven cars have lower price, car age is strongly linked with the price. In the training 4 ML models, I have trained four different ML models: linear regression, random forest, XGBoost, and deep learning MLP network. Each model was trained on the learning data and evaluated using R squared mean absolute error. This allowed me to compare their performance. As we can see, XGBoost saves as a best model performance as its R square and MAE is better compared to the others. Best model selection, XGBoost. After evaluating all the models, XGBoost performed the best with the R score, MAE, and tested on cars. In the actual versus predicted car prices, to demonstrate the model's accuracy, I have compared the actual price and the predicted price of the 15 cars. Also included, also included the car names for clear analysis. Most of the predictions were very close to the actual prices, confirming that the model is highly reliable. And in the end, XGBoost have the best charge score, MAE, total test cars. Final project conclusion, I built a complete end-to-end car selling price prediction system. The dataset was clean, processed, visualized, and analyzed thoroughly. Four models were trained and compared. XGBoost emerged as the best performing model, achieved 95% accuracy with low predictions error. The model worked well with the real world car name details. Newer cars with low mileage have high resale value. Diesels and automatic cars are priced higher. First owner cars command a premium. XGBoost captures complex patterns between the other models. This project demonstrates a practical presentation system that can help car buyers and sellers estimate the correct market value of a used car. Thank you for listening to my project explanation.